Hello and welcome to the 50th video in this series for beginners programming in C. Last video then we wrote the mydata.bin to our directory, the three structures that we'd defined, and this video we're going to read these back into an array, not into this array but into an array that we'll declare inside a function. And then after we've read these in and printed them to the screen, what we'll then do is actually read the structures in one at a time, so I can show you how you can dip anywhere into a binary file to get a specific chunk of data you need. So first of all, let's write a function called readSomeData, and inside this function I'm just going to declare an array, just as I've done here, called data array. Now remember, this data array has nothing to do with the one declared in the main, it's declared in the scope of this readSomeData function, so therefore is individual on its own, has no link to this one here. So to do this, we start off the same as we do with writing files and also with reading the text files. We need a pointer to our file, and then what we need is we need to open our file, which we just give the name here, and we specify the little r again for read, but this time we also specify a small b, just as when we were writing a binary file, this time to say we want to read a binary file. Now when we read a binary file, we do it by setting the position that we want to read from our pointer, and that position is set in bytes. Now if you imagine that, but we also need to tell in the read function how many bytes we want to read in. Now in this case we want to read in the entire file, so we need to know how many bytes are inside the entire file, and the way you do this is simply to move this pointer to the end of the file. And then you can call a function, which we'll see shortly, to say at what position is this pointer, and that will then return us when it's at the end of the file how many bytes forward into the file it is, or in other words the file size. Okay, that might not have made sense, but it will now because I'll show you how to do it. So the first thing, we need to move to the end of the file, and we do that using a function called fseek. And we need to say, okay, what are we moving? And fseek and all these functions in this in readSomeData here you can find on c++.com with a slightly more thorough explanation. We just need to put a 0 here. This fseek actually normally is used here to tell us how many bytes to move our pointer from its current point forwards. But here we just specify a 0 because as the third argument we're going to specify something called seek end, and that simply says go to the end of the file. And now we've done that, we can make a long called file size, and we use another function called ftell to simply get the position that our pointer is at, or in other words, the number of bytes forward it's moved now that it's been placed at the end of the file. The last thing we need to do, because we want to be reading all of our data from the start of the file, is call another function called rewind on p file, which simply brings it back to the start of the file. So all we've done is taken our p file, it was looking at the start, we've moved it to the end, we've used its current position to find out how many bytes there are, and then moved it back to the start of the file. And without further ado, let's just print our file size to the screen, just so that we know what's going on. I'll put readSomeData as a prefix here so we know where we are. And remember, when we print this, normally we would use the %d, but it's a long, so we need %ld, and we'll just take and drop our file size like so. And there we go. Okay, so hopefully we'll have got the size of the file there, which should be, I think, around 96 bytes. I think the structures are 32 each. Okay, so now we've done that, the next thing we need to do is we need to find out how many of our structures are inside our file. Well, we know already there are 3, but we'll do this for completeness. So let's make an int with numStructures, and we'll set this then equal to our file size, total bytes in our file, divided by then the size of our structure, which is the size of my data. Now the reason I've put all of this in brackets is because remember this is a long, so what we want to do is actually want to put this into an int like so, so we have our numStructures in this way, and what we'll do is we'll print the numStructures also to the screen, except this time it's just a d. Right, so now we're actually ready to read in the data. There's a return value which tells us how many of our specified blocks of data we actually read in. You'll see what I mean by the blocks of data shortly. And we'll just call this then our return value. And now we set our return value equal to something. and that is fread, and this is the function we call to actually read the data in the file. The first thing we need to specify is our stream that we're reading, so pointer to our file. Sorry, not the stream that we're reading, we need to specify where the data is going first. So it's going into our data array, and now we want to say for each chunk of data how much we want to read for each portion of data. Well, we want to read the number of bytes in our structure, which is size of and then our my data. And now we want to tell it how many of these chunks of data are we reading in. Well, we're reading in the num structures of the data because that's the entire file divided by size of my data. And now finally, where are we reading it from? Well, it's our file pointer. So what we can get here then is we'll put read some data, and this should tell us at the end our return value that we've read in 3 structures. So return value, and that should be a 3. And then last but not least, we ought to then print out the data that we've read. So we'll take from the main function, the same line already, print data array, and that's all there is to it. That should then have read in all of our data into our data array. So if I just go down into main, I'm going to comment out the print data and the write data to file, and in fact I'll comment out all of this because we don't need it. And now we'll call our read some data function, and like so, and save. And now just off screen I'm just going to quickly compile and see how many spelling mistakes there are. There don't seem to be any. Just run the program. Okay, good, and clear. Okay, so bring over the terminal. So again, for you, compile the program and now run the program, and you can see we have file size of 96 bytes, 3 structures, and it returned a value of 3, saying it read in 3 structures, and here are the structures printed to the screen. So that's the data read in from our my data binary file. Very good. But how do we then read individual structures in? Well, it's actually quite easy, and it involves simply using the fseek to tell it where we want to position our pointer to read in the data. So I'll make a new function here called read one data. So void, and we'll say read one data, and let's take an argument called index. Before we go any further on, let's imagine we've got a file, and this file contains 3 structures, but to keep things short, each of the structures occupies 4 bytes. So we've got 1, 2, 3, 4 for the first structure, 5, 6, 7, 8 for the second structure, 9, 10, 11, 12 for the third structure. Now these wouldn't be spaced obviously in a binary file, but it's just so it's a little easier to see, to visualize here. What we'll need to do is we'll be telling fread, as we've got here, that we want to read in 1 structure at size of my data, and what we need to do is position our stream point at the relevant place. So the index of the first structure obviously is index 0 and is looking then at byte number 1. The index of the second structure is at index 1 and is looking at starting at byte number 5, and the last structure is starting at byte number 9 with the index of 2. So in other words, all we do is we take in the index and multiply that by the size of the structure, which I said was 4 bytes just in this little example here, so I'd have to write out 3 lots of 32 dashes like that. So if it was 4 bytes, index 0 would start us here, and then that would start us then at the beginning of the 4th, and the next one would start us at the beginning of the well, it's here. I've just realised I've paused because I've just realised I've explained everything in terms of byte 1, in terms of byte 5 and 9, when in fact everything's 0 indexed in this case. I got a little bit confused with the explanation. Sorry. So I'll just start that again. Index times our size, which is 4, would start us at 0. If we want to look at the second structure, it would be an index of 1 multiplied by 4, would move us forward 4 bytes, so it would start us at this byte here, and then 2 times 4 would move us forward 8 bytes, so would start us at this byte here to do the reading. Sorry about that, I hope the explanation is now clear. The reason I mixed that up with ones is I've done this video twice. In the previous explanation I didn't do this diagram and did things with numbering the bytes 1 to 12. Anyway, excuses aside, let's get on with actually writing the function properly. So again, we need to define the data we want to read in, space for it, and also our file pointer, except this time it's not going to be array, we're just reading in one structure. And we open again our file for reading. And now this time the most critical bit is, again, we have fseek, and we're seeking, or we're going to position our pointer at the relevant point. So it should be fairly clear now that we use size of and my data multiplied by then the index that we've sent in. And this time, instead of using seek end, we use seek set. So we set the pointer at the position that we've specified here. So we moved along that many bytes. And now we've done that, we're in the position actually to read in our value. So let me just copy some more code from above to keep things zipping along nicely. Have our return value, and now we want to read from where our pointer is set. We want to read that into our data this time, and it's not a pointer, so we need to specify the address here that we want, the address operator, the ampersand here. Reading inside my data, this time we're only reading in one structure and from this stream. And last but not least, then we can, I'm just going to copy the line from print my data here. We can then print the data we've read in to the screen, and I'll also print the index as well, like so. And we don't need this because we've just got the data structure, it's not an array. And here I'll just put index like so. So this will then read in the data at the specified index. So down into main, just take this out, and we'll make a for loop to loop through all of the structures. So int index equals 0, and then I'll say for index equals 0, and index is less than num data, which is our 3, index plus plus. And now we can get our read one data, just copy the name with index, and everything should work okay here. So just off screen with the terminal here, well, not off screen, let's compile it live and see how many mistakes I've made, not too many. And now let's run the program, and you can see that index 0, it read in our dog. At index 1, it found and read in our beer structure, and in index 2, it found and read in our iguana structure from the file. Good, so that's it then for this video. I hope it made some sense, and that's the last video completed on reading and writing text and data to files in C. So thanks very much for listening, and comments, questions, criticisms welcome as always on YouTube.